By now, one would already figure out that no matter how complex a function is, root finding follows a pattern according to the method used. Check the next example here in numerical solutions to CE problems. Let's have a quick background of the method's concept before we solve for a root. Given a function, we are to look for the x-intercept of an interval. Saying that we already have the initial values, they are illustrated as point A with x distance of xa and y distance of f of xa. This point is taken from an assumption. The second point is also assumed, and from the illustration, the x distance is xb and its y distance is f of xb. Since Newton-Raphson uses differentiation, which we are trying to avoid in this method, we will use secant line instead of tangent line. This line connects the two limits. We need to derive the function of the succeeding x values until we reach the root. First, we separate the numerator from the rest of the second term of the function. The denominator is where f prime is. Instead of using calculus, let's just take the computation of slope using 2 points. By taking the small triangle created by the secant line, we take the rise of the triangle as f of xa, less f of xb. The run is also taken as xa minus xb. Plug this slope formula into the function, then flip the denominator down below. This function is used to determine the x location of the succeeding x in the iteration. The function we are to use in this example is 2x cubed sine of x less 4x squared minus 3. The root we wanted is nearest the origin, and it is a positive root. We are again to follow 4 decimal accuracy, and the initial values we use are whole numbers. We start by assuming some positive values to find the interval. And since we are to take the root nearest the origin, we start at 0. By plugging 0 into the function, we get negative 3. Then, we use x of 1, which gives f of 1 as negative 5.3171. We then try x of 2. Then the function becomes negative 4.4512. It is still negative, so we keep on assuming positive values. Try x of 3, which makes the function negative 31.3795. With x of 4, the function becomes negative 163.8707. Another negative value, so we try x of 5. And when 5 is placed into the function, we get negative 342.7311. If we persist and use x of 6, the function becomes negative 267.7075. But still, we try x of 7. And the function using 7 as x becomes 251.6928. Finally, we have a function of x which is positive, so we have a sign jump. And we can then say that the root of the function lies within x of 6 to 7. After knowing the initial values, we work on a table. Let's start with the left limit in the second column and right limit in the third. To easily use the secant function, we tag each column as xa, xb, then f of xa, and f of xb. Let's then place the initial values where 6 is xa and 7 is xb. The function of xa is also solved earlier as negative 267.707495, while that of xb is 251.692807. After the initial row, we can iterate to find the root. Slide xb into xa, and also f of xb into f of xa. The new xb is computed from the secant function, which is 6 minus negative 267.707495 multiplied by 6 less 7 over negative 267.707495 less 251.692807. x2 is simplified as 6.515417. Use this value to take f of x, which is twice of 6.515417 cubed, sine of 6.515417 minus 4 times the square of 6.515417 less 3, which turns out as negative 45.491205. Again, slide xb and f of xb into xa and f of xa. Then solve for the third xb using the secant function, and have 6.589594. f of xb is also solved by plugging x of 6.589594 into the function to have negative 4.071463. Both the functions are still far from 0, so we need more iterations. Slide xb and f of xb again, then use secant function to take x4, and that is 6.515417 less negative 45.491205 times 6.515417 less 6.589594, all over negative 45.491205 minus negative 4.071463. So x4 is 6.596885. Use this value into f of x and get 0.104289. We have already reached 0.104289, so we are near the root. For the fifth iteration, slide values from the b's to the a's. Then use secant function to solve for x5. Plug in the necessary parameters from the fourth iteration to have x5 as 6.596703. We then solve for f of xb using the value we just computed. So f of x is twice of 6.596703 cubed times sine of 6.596703 minus 4 times the square of 6.596703 less 3. So f of xb is negative 0.000165. This value we just computed qualifies in the 4 decimal accuracy we needed. But then, let's iterate one more to check if we can have convergence. Again, slide xb and f of xb into xa and f of xa. Then solve for the new xb. Plug in all the parameters from iteration 5 into the secant function to have x6 as 6.596703. This is the exact xa value, so f of x would also be negative 0.000165, which shows that we already reached convergence. And thus, the root is truly 6.596703. Let's then verify if we end up with the same root when the limits are interchanged in the table. That's if the right limit is placed first in column 2, followed by the left limit in column 3. This means that 7 is written first before 6. So the respective functions are 251.6928 for xa, and f of xb is negative 267.707495. Start iterating by sliding values. So xa is 6, and f of xa is negative 267.707495. The new xb uses the secant function, and using the first iteration values. x2 is then 6.515417. Plugging this value in f of x, the last column is filled with negative 45.491205. The third iteration follows the same pattern of sliding the b's. Then take x3 by using the current figures, and have 6.620931 for x3. f of x with this value then is solved as positive 14.001482. The next iteration has the same process of sliding the values to the other side. Then solve for the new xb as 6.515417 less negative 45.491205 with a difference of 6.515417 and 6.620931 divided by negative 45.491205 less 14.001482. This results to 6.596098. This value is used to find for f of x, which is twice of 6.596098 cubed, sine of 6.596098. Then subtract 4 of 6.596098 squared less 3, which is negative 0.347311. Then again, slide xb and f of xb to the other side. Then solve for the new xb from the values of the fourth iteration. The outcome is 6.596699. By plugging this value, we get f of x as twice of the cube of 6.596699 times sine of the same figure, minus 4 of the square of 6.596699 minus 3, which results to negative 0.002461. The last column shows that we already have 2 decimal zeros, so we are near the end of the iteration. Do the same process of sliding xb and f of xb to xa and f of xa. Then compute for the new xb as 6.596098 less negative 0.347311 times 6.596098 minus 6.596699 all over negative 0.347311 less negative 0.002461. The result is 6.596703, which is then used to solve for f of xb, which eventually becomes negative 0.000165. We have already reached the root from the previous arrangement, but then we try to check for convergence. So slide the values of xb and f of xb again, then solve for xb, which then gives the same value of 6.596703. Needless to say, the new function of xb is the same as the plugged value. The function is negative 0.000165. By completing the seventh iteration, we can see the convergence from columns 1 and 2. So we can say the root of the function is at x of 6.596703.